Okay, now listen. 9.1 NCERT example 9.1 from hydrocarbon. First, all nomenclature you can solve right now. IUPAC nomenclature. Then 2, 4, up to 4 you can solve. Now 5 number. He asked an alkane A on ozonolysis gives a mixture of ethanol and pentanol. Right now pentane 3 on. Write the IUPAC name of A. What will be A? Right now. He asked. He gave this data right now. Ethanol and pentane 3 on. He gave. And ozonolysis. We know ozonolysis. What the reagent of ozonolysis? Ozonolysis reagent O3 plus Zn plus H2O. Right now. Reductive ozonolysis. Right? Reductive ozonolysis. Reagent is O3 Zn plus H2O. Right now. Zn plus H2O. This is the reductive ozonolysis. And we know double bond ozonolysis celebrate the happy birthday of double bond. Right? He cut the double bond. Right? Means he cut the double bond and he distribute cake right now between double bond. And this cake, if he'll give the product, means you have to remove that cake, oxygen, and add the double bonds right now. Now form here CH3, CO, H, and now this oxygen come here, take CH2, CH3, CH2, CH3. Now this is the same compound right now. Same compounds, only arrangement is different. Listen carefully. Same compounds, only arrangement is different. 1, 2, 3. 3 get on right now. Means now remove the oxygen and add to this ones. Okay now. Now what the name of this compound? What the name of this alkane? Numbering will start from this side or this side? 1, 2. This is correct. From here numbering will start. No. If from one side 2 carbon, right now 2 carbon, one side 2 carbon, this carbon, and one side this one, as it is. I wrote here right now. As it is. Means numbering will start from IUPAC nomenclature. Remember the IUPAC nomenclature. Okay. What is the rule? Functional group, give the priority first to the functional group, then multiple bond, then number of carbon, then substituent. Right? There is any functional group? No. Multiple bond? Yes. Means lowest locant give to the multiple bonds. Right now. Means from here or from here. From where we get the lowest locant? Here now. Means 1, 2, 3, 4, 5 or 4, 5. Any side you can move, right? Means what is the name of this compounds? 3-thyl, pent-2-ene. Right? Correct. Correct, Sujata? Nomenclature incorrect. Correct. Raxia? Correct. Okay. Now, understood now these questions? And now next question is 9.6. He gave the data right now. He gave the some data and he asked about A, means substrate right now. Means he asked an alkene A contain 3 carbon single bond carbon. Okay, na? Carbon single bond carbon 3. And there is a 8 carbon hydrogen bond. There is a 8 carbon hydrogen bond. And sigma and carbon hydrogen sigma bonds. These all are carbon and carbon hydrogen sigma bonds only, right? Now one carbon pi bond is available. One pi bond is available. And on ozonolysis, this alkene, right now this is the alkene. And ozonolysis of this alkene, he gave aldehyde, mixture of aldehyde. Okay na? Aldehyde, 2 moles of aldehyde. He gave in a product 2 moles of aldehyde, and he gave the molar mass of aldehyde. What is the molar mass of aldehyde? 44 unit. Means 44 EMU right now. Unified mass EMU, right? 44 unit. He gave the 44. Means now you have to find the IUPAC nomenclature of A. Now let me check. Carbon carbon 3 bonds, right now. Carbon carbon 1 2 3 bonds, right? And now carbon, one carbon having double bonds, right now. One carbon having double bond. And he said 2 moles of aldehyde. Means that is the symmetric aldehyde. Means from this line you have to find out, right now. Means this is the symmetric aldehyde because he said 2 moles, right now. 2 moles means if there is a same number of carbon both side, only that time is possible, right now. 2 moles. Means now this double bond, location of double bonds, how you can find? By moles of aldehyde, by that given data. He gave 2 moles of aldehydes form, right now. Means from here, and he said both 2 moles having same molecular weight 44 unit, right now. 44 unit. Means now, and how many hydrogens are there? 8 hydrogen, CH3, H, 8 hydrogen completed. 3 carbon carbon bond, 1 2 3, 8 hydrogen carbon hydrogen, 1 double bond finish. Ozonolysis, happy birthday, and oxygen distributes, okay now. And now form 2 moles of acid aldehyde. Now check the molecular weight of this aldehyde. Check molecular weight of this aldehyde. 12 plus 12, carbon atomic weight is? Carbon atomic weight? Huh? You forget Nitila, right? Huh? 12, 24 plus 4, 28 plus 16, 44, right now. Means correct data we get as given, right now. Correct data we get 44 unit, 44 mass. Means what is the alkene name? What is the alkene name? 1 2 3 4 butene, right now. Butene. Understood everyone? Nitila, you get the answer? Sujita? 9.6 butene, correct? Okay. Now next one, 9.7. He gave the propanol and pentanthreone. What? Propanol and pentanthreone. And he asked, give the alkene name, right now. What is the alkene? A structure formula of the alkene. By ozonolysis of this alkene, this product form. Very easy, you can form right now. Means same like this. This is the reverse form of reactions. Alkene, this side, ozonolysis, this product form. What is the propanol? C. Right? This is the propanol and pentanthreone. This is the pentanthreone, right? First draw the structure. And now what is the punchline for ozonolysis? Happy birthday of double bond, right now. Means reverse form. Remove the oxygen and that double bond attach, right now. Double bond attach, simple. Means now take this carbon and one side 2 carbon. There is a one side, one branch having 2 carbons, right now. 2 and one side 2. Now remove the oxygen and join the bond. What product? What the name of this product? Numbering will start from right to left or left to right. Numbering start from left to right or right to left? Huh? Numbering. 1 2 3 4. Right now here 3 and 4. What the location we get? 3 of double bond. First priority give to the double bond, right now. First check the double bond. 1 2 3 1 2 3. Both sides same we get, right now. Means now branch subsequent, lowest locate of branch. 1 2 3 4. From this side 4 and from this side, means this side 3 4 and this side 3 3. Which one is the lowest locking? 3 3 right now. So this one is a correct, this one is a incorrect right now. So 1 2 3 4 5 6. What is the name of this alkene? 3-ethyl hex 3 in right now. In NCERT what is the given answer? 4-ethyl, no? That is incorrect, right? 4-ethyl, that is the, this is the lowest locking, right now, according to the rule, right? This is the lowest locking. Otherwise, if you can give the 1 2 3, same, no? 1 2 3, 1 2 means this side or both you will get same, right? Now 9.8. Write the chemical equation for combustion reactions of the following hydrocarbon. Combustion reactions of the following hydrocarbon. What is the product of combustion reactions? Complete combustions. CO2 plus H2. Write the substrate and burn that compounds, okay na? And form the and balance the equations, okay? And now 9.9. Draw the cis and trans structure of hex 2-ene. Which isomer have the higher boiling points? Okay now, higher boiling point. There is this question I will discuss when again I will start the isomerisms. Okay now, because physical property I not discuss right now. Physical properties I not discuss there. I will discuss after finishing this chapter. Again I will start the isomerism chapter. Okay now, don't worry. So there I will discuss this cis compound is a more polar. Cis compound is a more polar, that's why cis compounds having more boiling points. Trans compound, now cis and trans compound melting point is high. For trans compound melting point is high. Why? Because it is the compactly packed structures. Okay now, trans compounds, it in a lesser space more compounds can come, so that's why it's a melting point increase. But boiling point, cis compounds having more. Understood? Now, 9.10. Why is a benzene extraordinarily stable through the containing 3 double bonds? Can you explain it? Why extraordinary stables? Aromatic, first factor is aromatic right now. Second factor is a bond angle. Right now, and all having resonance, that's why it is aromatic, na? Having resonance, that's why it is aromatic. Conjugations, always we check the conjugation, right now, conjugated pi electrons. After that we are saying this is the aromatic, non-aromatic or anti-aromatic, right now. Right. Now, why this is the extra stable? Because there is a bond angle also, carbon and carbon. What is the bond angle here? More than 120, right now more than 120. So that's why it is the extra thing also. And all unpaired electrons are present in a p orbitals right now. That pure p orbital, and attraction is a good attractions and it form a stable pi bonds, right? And conjugated pi bonds. Now 9.12. Explain why the following systems are not aromatic. These compounds are not aromatic. Why? First, in a first compound, there is a one sp3 carbons right now. sp3 carbon come in that compound is non-aromatic, right? This compound, this one is a one sp3 right now. If I add here negative charge, that time it is a aromatic. Now anti-aromatic right now, because it is the gas, but this negative charge is the part of this benzene right now, because this negative charge present on a carbon, so that's why it's become aromatic. But when we'll take the pi carbon, pi electrons like this, that time it is the gas, only he can take or he can give the electrons to the systems right now. So that's why it's become, and having containing 4 pi electron means anti-aromatic. Now this compound is anti-aromatic. This compound is anti-aromatic. Non-aromatic, a special case right now. Due to 8 carbons and conjugated, it's a 8 carbon ring is unstable right now, and it rotate and bend like a which shape? Tube shape right now, tube shape, and its planarity get disturbed. Means it's looking like all pi bonds are in conjugations, but here is a no conjugations right now. Looking like it is conjugations, but due to non-planarity, for conjugation, first conditions was planarity right now. Atom should be planar. This was the first conditions for resonance. Means atom should be planar. If planarity get disturbed, how it will show resonance? There is a no connections between pi right now. So that's why this compound change to tube shape right now. Tube shape, and there is a no conjugations, looking like conjugations but not conjugations. Okay now, a special case, always remember it. See the non-aromatic. Okay, now 9.13, how will you convert into, this question is good right now. There is a, here you can think. Okay now, here you can think better. Okay, means how you can convert benzene into, means from benzene to this given products. Okay now, first compound is a para-nitrobromo-benzene. Means from benzene to, how you will convert into, what is the para-nitrobromo-benzene? Means here, who is the, no, here you have to think, who is the director, nitro or bromine? Bromo or nitro, who is the director? Bromo. That's why para product is possible right now. If you will take nitro director is as a nitro, that time meta products form right now, meta products. So be careful, okay now, in this type of questions. Okay, now here director is a bromine, that's why nitro compound is formed. Now first of all, from benzene to, you have to convert into bromobenzene. And what is the reagent for bromobenzene? Halogenations right now, halogenation, ESR reactions, right? Example of ESR, halogenation first. What is the reagent of halogenation? Br2 plus ElCl3 right now. Lewis acid, you can take any Lewis acid. Br2 plus ElCl3 means Br2 plus ElCl3, bromobenzene form. Now, what the process name after bromobenzene to nitrobenzene? Reaction name? Nitrations. Very good. Nitrations right now. Means addition of NO2. Right? And here a special is, what is the special here? Both are acid. HNO3 plus H2SO4, both are acid. But who is behave like base? HNO3 right now, less acidic, that's why it behave like base. Right? HNO3 plus H2SO4. These are nitrations. Electrophile NO2 right now. Electrophile is NO2. Means it will add here. Ortho product is also possible, but major is what? Para. So directly write that. Not meta, para. Means how many steps required for converting benzene to nitro, this compounds nitrobromobenzene. Nitrobromobenzene. How many steps required? 1, 2 steps, right? 2 steps required. Understood? Now next question. From benzene to nitrochlorobenzene. Nitro meta. Here is a special meta nitrochlorobenzene. Means who is director here? NO2 right now. DZ group. Here director is DZ group. That's why meta product is possible, right now? Daisy group. This question is correct now, Mithila, last, Sujata? Okay, good. Now, chloro, nitro, chloro. Now from here, what will you add first? What will you add first? Nitro or chloro? Nitro, obviously nitro. Means for getting the meta product right now. Means what the reagent? HNO3 plus H2SO4. Electrophile, always for solving the questions, always try to write the electrophiles, okay na? Always. Means when you will write na all datas during solving the questions at home, practice, means you will remember, okay na? Otherwise you have to give the extra time for remembering the electrophile, reagents, okay na? If you know the reagents with electrophiles, in a one line you can write NO2, okay na? Directly NO2 add here on benzene. Now, what the reagent for adding of chlorine? Halogenations, right now. Reagents Cl2 plus ZnCl2, FeCl3, AlCl3, anyone you can take right now. Means product will form here. And some temperature we have to take here, some temperatures, because this benzene are deactivate, right now benzenes get deactivate, mean there is a less electron densities, right? So some temperature we have to take here, okay, for adding the metachloro. Now this is the correct metachlorobenzene. Para-nitrotoluene, how you will convert? One step or two step? Para-nitrotoluene means from benzene to para-nitrotoluene. First of all, what will you add here? CH3, right now? CH3. That reaction name is Friedel-Crafts alkylations, right now. What is the electrophile here? Alkyl, right now? Alkyl. Generally say alkyl. Now, first Friedel-Crafts alkylations, right now? Friedel-Crafts alkylations. Reagent name is first toluene form. So you have to take the methyl, right now. Here is a methyl carbocation, right? CH3 positive charge. CH3 Cl plus AlCl3, right? Methyl form. And from this compound to these compounds, in a methyl, orthonitrotoluene is a measure or para-nitrotoluene is measure? Orthonitrotoluene is measured products, right now. But here what he asked? Para. So give the para, right now. But remember this, orthonitrotoluene, in a toluene, a special case, okay. Whenever toluene undergoes chlorinations or nitrations, ortho product will be measured, right now. Ortho product will be measured. Second case, when phenol show hydrogen bonding, that time ortho product will be measured. And for remaining, generally para product is measured, right now. So here he asked para-nitrotoluene. Okay, no problem. Both products you can give right now. Means nitrations. Here is a nitration. HNO3 plus H2SO4. Correct. Nitrations. Two products will form here. But he asked minor. So no problem. Give the answer for minor right now. But write also major products. This one is a minor. This one is a major products. Okay, understood now? Sati, what happened? headache. Solve the question. Very easy. If you solve the NCERT question, na, all question you can solve. If you can solve the NCERT question, advanced level question, very easily you can solve. Very easily. Okay. Like chain reaction, he asked in advance. Okay. Multiple steps. Multiple steps. Next, what is the fourth number question? Acetophenone. Now, here is a twist. How you will form the acetophenone? First of all, you don't know the acetophenone structure right now. You know the acetophenone structure? This is the acetophenone, right? This is the acetophenone, na? Huh? No? Then? This one? No. This one is a acetophenone. What groups are added here? Huh? Acylations, right now? Acylation means if you know the structure, right now, half question solved, right? If you know the product structure, half question solved. Only now, which group is this one? This is the acyl group. Means Friedel-Crafts acylations, right now. Friedel-Crafts acylations from benzene to Friedel-Crafts acylations. Means what the reagent? You can take acetic anhydride, acetic chloride, right now. You can take anyone. Means CH3, CO, Cl, Al, Cl3. Direct in a one step this product form, right? Only ask para, what he asked? Acetophenone, no? Acetophenone directly you can form compounds, right? Acetophenone. Understood, everyone? Now, 9.14, take the time from 14 to 16. 14 to 16 solve. Now, you have 5 minutes time, okay now? After that, I'll continue again.